Hello all, welcome to Bodhana. As part of lecture series for BTech students, here in this video I am going to discuss about the applied physics syllabus importance. As we discussed in the previous video, the total applied physics consists of 5 units. The first one, the quantum physics and solids. Second one, semiconductor devices. Third one, magnetic materials, dielectric materials and the energy materials. And the fourth one is the nanotechnology. And the fifth one is the optical fibers and lasers. Coming to the first unit point of view. Here the name itself, quantum mechanics and solids, and generally we call it as quantum physics and solids. As you know that there are different mechanics: classical mechanics, quantum mechanics, statistical mechanics. There are several ways we call it as mechanics, but every theory related to the mechanics is different. Classical mechanics is not same as the classical mechanics, and the classical mechanics is not same as the statistical mechanics. Here the point is, the failures of the classical mechanics is one of the origin to invent or to establish the quantum mechanics. For example, as we know that the classical mechanics is completely based on the Newton laws, the first law, second law, third law. Everyone know about these laws, and by using that laws we can explain the behavior of any kind of object. If it is moving, if it is in rest, if it is getting acceleration. So the complete theory related to the objects we can explain by using the classical rules like Newton first law, second law and third law. But the problem is, all these objects are in macroscopic and bigger objects. This classical mechanics is well suited for the bigger objects. But what about the microscopic particles? కంటికి కనిపించిన పార్టికల్ గురించి ఏంటి? ఎలక్ట్రాన్స్, ప్రోటాన్స్, న్యూట్రాన్స్ are very microscopic particles which are not in big size. If you want to explain the behavior of that microscopic particle, classical mechanics is not at all suitable. For example, black body radiation. The substance emitted by the radiation is, if the substance is in black color, generally we call it as black body radiation. How the radiation spectra is distributed according to the wavelength or the frequency is not able to explain by using the classical mechanics. And it is well known that electrons are revolving around the nucleus. See, if you are doing some work, obviously after 30 minutes, the 40 minutes, the 1 hour, the 2 hours, obviously we lose our energy, we can't do work. But electrons are keep on doing work in particular orbit. How it is possible? That theory is unable to explain by using the classical mechanics. Even according to the classical physics, energy distribution is continuous. But the reality is, we just discussed in the intermediate Lyman-Balmer patch and bracket fund series. So that is the line spectra, discontinuous. Photoelectric effect. According to the classical physics, we feel that intensity a bigger role, but according to the photoelectric effect, frequency is the bigger impact in emitting the electrons. So not only this, how the materials are classified like a magnetic, dielectric or any other materials, how the materials are classified into the conductors, semiconductors and insulator, all these theories are related to the quantum physics, microscopic particle, because it is unable to explain by using the classical physics. This is one of the origin to invent or to establish the quantum mechanics. So obviously now you have clear idea why we need to read about the quantum physics. Coming to this particular chapter, so we just discussed about the introduction to the quantum physics. Then obviously in that part, why classical physics is failed in explaining the black body radiation. In explaining to explain the black body radiation spectra, Planck assumed a model, that is the Planck's radiation model. In that model only the famous photon concept is introduced. In addition to this, photoelectric effect. What is the meaning of photoelectric effect? How it explained by using the different scenarios. That part is related to the photoelectric effect. In explaining the Planck's radiation law, photoelectric effect, etc., etc., we just observe the things like particle nature and the wave nature. As we know that light is a wave because it emits it follows the like interference, diffraction, polarization, etc. But photon concept introduced the particle concept. Then obviously now we have a dilemma whether the light is a particle or the wave. In that case, dual nature is introduced. Dual means both. So sometimes it behave like a particle, sometimes it behave like a wave, because photoelectric effect is the one of the proof for the particle nature. Compton effect is another proof for the particle nature. Interference, diffraction, polarization, these are the proofs for the wave nature. Then finally, so we compromise ourselves and we are agreeing that light has a dual character. So to explain, de Broglie introduced every moving particle is associated with a particle that is called as matter wave. Experimental verification is done by Division and Germer's experiment. Mathematical proof is given by Schrödinger. Applications of the Schrödinger explanation for the particle or the matter wave is particle in one-dimensional box. This is just an example. And uncertainty principle. Heisenberg uncertainty principle. It is impossible to measure both the position and momentum simultaneously and accurately. Whatever the kite you construct, but there is some uncertainty. That gives the uncertainty principle. This part is there related to the quantum physics. But coming to the solids, as we know, the solids are classified based on the free electron nature. If it has more free electron, these are called as conductors. Less insulators. Less insulator means bounded electrons is insulator. Medium, it is called as semiconductor based on the conducting nature. Conduction, that is the current, is nothing but rate of flow of charge carrier like electrons. But how it can move? If it is free, then only electrons can easily move. If it is bound, there is no electron can move. That is only the classification between the materials like solids, like conductors, insulators, and the semiconductors, etc. So to explain the electron behavior, we have different theories. Free electron theory, it's explained by Lorentz and Root and Sommerfeld, etc. And Bloch theorem, Croning-Penny model. So some are related to the constant potential. That means the electron is moving in a constant potential is related to the one theory. It's a variable potential is the another theory. In that case, electron won't behave like its original mass. Electron differently behave, that is called as effective mass. And origin of energy bands, how the energy bands are created, because we are talking about the conduction band and say valency band. If these bands are clumped closer, that is called as conductors. If there is small gap, that is called as semiconductor. If the gap is more, that is called as insulator. How we can discuss what is the origin to create the band? That is one part we need to discuss in the part of solids. And again, based on the energy gap, solids are classified into the conductors, insulators, and the semiconductor. Finally, the chapter 1 is related to the quantum physics and solids. Thank you.